let's talk about one of the biggest challenges in tech today. How do you actually build and manage all the complex stuff that runs in the cloud without, getting completely overwhelmed by manual, tedious, and error-prone work? Well, the answer isn't just a new tool, it's a completely different way of thinking about infrastructure. I mean, seriously, picture this. You're not just responsible for one server anymore. We're talking hundreds, maybe thousands, and every single one needs to be set up, networked, and locked down tight. If you try to do all that by clicking around in a web console, well, it's just not going to work. It's a recipe for disaster, and it's the exact problem that forced a revolution in how we do things. And that revolution is called infrastructure as code, or IAC for short. The big idea here is brilliant. You treat your infrastructure, all your servers, your databases, your networks, the whole shebang, you treat it just like you treat software. You write it down in code. And once it's code, it becomes predictable, repeatable, and you can automate it. And right at the heart of this whole movement is a tool called Terraform. So here's what we're going to cover. First, we'll nail down what Terraform actually is. Then, we're going to peek under the hood and see how it thinks. We'll walk through the core workflow, cover some super important best practices, and then wrap up with something crucial: how to test your code. All right, let's dive into section 1. We've got to start with the single most important concept about Terraform, and that's its declarative approach. This one idea is what makes it so different. So what on earth does that mean? Well, think about it like this. An imperative approach is like giving a chef a super detailed recipe. Step 1, chop the onions. Step 2, preheat the pan to 375 degrees. Step 3, you get the idea. You're telling them exactly how to do everything. Terraform's declarative approach is totally different. It's like telling the chef, I want a thin crust pizza with pepperoni and mushrooms. You just describe what you want in the end, and you trust the chef, in this case, Terraform, to figure out all the steps to get you there. And that right there is the magic. You don't get lost in the weeds of the how. You just define the what. You say, I need a web server, a database, and a network to connect them, and Terraform's engine is smart enough to handle all the complicated logic to make it a reality. Okay, so how does it actually pull that off? It's not just magic, I promise. Let's look under the hood at how its core engine thinks, because it's really a team effort between 3 key parts. First up, you have Terraform Core. This is the brains of the whole operation. It reads your configuration files, it understands all the relationships, like, hey, this server can't exist until this network is created, and it builds a whole dependency graph to figure out the most efficient plan of action. But the core doesn't actually talk to AWS or Azure directly. For that, it needs something called providers. Now, the best way to think of these is as universal translators. There's an AWS provider, an Azure provider, a Google Cloud provider, thousands of them. They take the plan from the core and translate it into the specific API calls that each individual platform can understand. This is what makes Terraform so incredibly versatile. And the last critical piece of this puzzle is the state file. This is Terraform's memory. It's just a JSON file, but it acts as a perfect blueprint of what you've actually built in the real world. So when you change your code, Terraform looks at your new code, compares it to this state file, and it knows exactly what's different. This file is the single source of truth that lets Terraform know what it needs to create, what to update, or what to destroy. Okay, so now that we know all the components, how do we, actually use them? Well, it all boils down to a really straightforward 4-step workflow. It's like a simple little dance. First, you write your code, defining everything in a language called HCL. It's pretty easy to read. Next, you init, which is a quick command that just downloads the providers you need. Then comes the most important safety check. You plan. This shows you a preview of everything that's about to happen. And finally, once you're happy with the plan, you apply it, and Terraform makes it real. I have to stop and really emphasize this plan step. This is your safety net. It's your measure twice, cut once moment. It gives you this beautiful, detailed report showing you exactly what's going to happen. You'll see green plus signs for things being created, yellow squiggly lines for things being updated, and scary red minus signs for things being deleted. You review this, and only when you say, yep, that looks right, do you move forward. This one step will save you from so many headaches. So knowing the workflow is one thing, but using it effectively when you've got a whole team and a complex system, that's another. So let's talk about some best practices for building infrastructure as code that's actually solid and easy to maintain. This table really breaks it down well. First, structure. You've got to think in modules. These are like reusable Lego blocks of code that stop you from repeating yourself. For naming, just come up with some simple, clear rules. Trust me, your future self will thank you when your code is easy to read. Now, security. This is a big one. You absolutely have to use a remote state file. This keeps your state files somewhere safe and shared, which prevents team members from tripping over each other. And finally, your workflow. Plug Terraform into your version control, like Git, and automate it in a CI/CD pipeline. This makes your whole process faster, safer, and way more reliable. And that brings us to our final and maybe most important section, testing. Because if you're going to treat your infrastructure like code, then you absolutely 100% have to test it like code. Let me just say that again so it sinks in. Your infrastructure code is still code. A bug in this world doesn't just crash an app. A bug could delete your entire production database or accidentally open up a huge security hole to the entire internet. So yeah, testing is not optional. It is a professional requirement. And the great news is there's a whole world of tools to help you out. You can start with something called TF-Alint. Think of it like a spell checker for your Terraform. It catches simple syntax errors and best practice mistakes right away. Then you can add a layer like Checkoff, which is a security scanner. It'll comb through your code looking for misconfigurations that could leave you vulnerable. And for the ultimate peace of mind, you've got tools like TerraTest. This thing will literally build your infrastructure in a temporary environment, run a battery of tests against it to make sure it works, and then tear it all down for you. It's amazing. So when you step back and look at the whole picture, the big takeaway is this. Terraform is so much more than a tool. It's a complete shift in how we approach building things. It takes what used to be a really stressful, fragile manual process and turns it into something that's automated, that's reliable, and that's as easy to manage as any other software project. By turning your infrastructure into code, you unlock a level of speed, safety, and consistency that just wasn't possible before. It frees you and your team up to stop worrying about the plumbing and start focusing on building amazing things. So the only real question left is, what are you going to build with it?